Welcome to section 6.5, factoring polynomials. So we're going to be focusing on four-term polynomials and quadratic functions that have a leading term that's not 1. But we're going to start with factoring a polynomial with 4 terms, and we're going to do that by grouping. So here's an example right here. 2x cubed minus 4x squared plus 5x minus 10. So remember, our first step when we always factor polynomials is we check for a greatest common factor. And we don't have one because of 2, 4, 5, and 10. There's no common factors for the constants, and there's no variable in all the terms. So our next step is to count the terms. And we have 4 terms. And 4 terms means we factor by grouping. So we factor by grouping. So what that means is we are going to take our polynomial, 2x cubed minus 4x squared plus 5x minus 10, and we're going to group them in 2 groups of 2. And we can use parentheses like this. And from each group, we're going to factor out the greatest common factor. So in this first group, that would be a 2, because between 2 and 4, the greatest common factor is 2. Then we have an x cubed and an x squared, so we're going to take the smallest power, x squared. And then again, to factor that out, it's like dividing each of those terms by 2x squared. And so we're left with x minus 2. And we can always check by redistributing. 2x squared times x is 2x cubed. 2x squared times negative 2 is negative 4x squared. And we're going to repeat the process in that next group. 5x minus 10. 5 is a common factor between 5 and 10. And then that's it. So what we're left with, we can also think of it like this. 5 times what is 5x? So kind of distributing as we go. And then 5 times what is negative 10? 5 times negative 2 is negative 10. All right, and then when we do this, we have 2 terms now, right? We have this part, because it's a product, so it's a term, and we have this part. And then notice in parentheses, this x minus 2 and this x minus 2 is in common. So that's going to be something we can factor out. So we're going to take out that 2x minus 2, excuse me, that x minus 2. I can put it over here. Oops. X minus 2. And then we're left with 2x squared plus 5. All right, and then this is our final answer, 2x squared plus 5 times x minus 2. And I wanted to point out that if we were to redistribute the x minus 2, we would give a copy to the 5, and we would give a copy to the 2x squared. All right, so let's look at our next example. Really similar from before. There is going to be one difference, and I'll show you what that is right now. So first step is always the same. Is there a greatest common factor? And there's not. And then we count the terms. 4 terms means factor by grouping. All right, so it's important to count the terms. That tells you your strategy. This one's a little bit different because our second group of 2 has a negative in front of it. So we, again, group 2 groups of 2, but the second group starts with a negative 2x. So we're going to get that negative in the parentheses. So we can think of this as like adding a negative number. All right, so the first part's the same. The first group on the left, so we're going to figure out the greatest common factor and factor it out. So between 6 and 9, the greatest common factor is 3. And between x cubed and x squared, we're going to take the variable that's in common and use the smallest power. So it's going to be x squared. And let's see what we're left with. We're going to be left with, so again, we can divide out 3x squared from both the 6x cubed and the 9x squared, or we can distribute as we go. So we can think 3x squared times what gets us back to 6x cubed? Well, 2x, because 3 times 2 is 6, and x squared times x is x cubed. And we can do the same thing with the second term. 3x squared times what is 9x squared? Well, 3x squared times 3 is 9x squared. There you go. All right, so let's look at our next group over here. So notice between 2x and 3, nothing's in common. No factors are in common. So we can think of this as 1. The common factor is 1 since there's nothing else. But it's a special kind of 1 because it's a negative number. Remember, we don't like to start off with a negative leading term. So we're going to actually factor out a negative 1. All right, so first of all, there's nothing in common, so we could just think of that as factoring out a 1. And because the first term is negative, we have to factor out a negative as well. So essentially what that's going to do, it's going to flip the sign of everything in that parentheses. And now when we do that, we see our common factor. 2x plus 3 is a common factor in both. So we're going to factor that out. We're going to pull it out of both terms, from both terms, and we're left with 3x squared minus 1 times 2x plus 3, and that's your final answer. All right, so let's try one on our own. So you guys can push pause and then work out your solution and then come back to see how you guys did. Okay, so hopefully you guys did those first 2 steps. You checked for your greatest common factor. And then you counted your terms up. And so you know this means factor by grouping. All right, so because you're factoring by grouping, you're going to come in and you're going to create 2 groups of 2. And our second group has a negative, so let's make sure the parentheses includes that negative for your second group. All right, and now let's factor out the greatest common factor in both. So in this first one, 3ax plus 7ay, the only thing in common is the a. The only thing in common is the a. And then we're left with 3x plus 7y. All right, and then in the next set of 2, group of 2, it starts off with a negative, so we do have to factor out that negative. And then let's see, we have a b squared in common to both. So we're going to have to factor out a b squared, and we're going to have to turn all the signs, switch all the signs because we're factoring out a negative. And so we're left with 3x. Negative 7 is going to be changed to positive 7y. All right, I messed up my color coding. Here we go. So we have this 3x plus 7y in common to both terms. So that means we can factor it out from both. And that's going to give us our final answer. All right, and then just a quick note, you guys can state this as your answer. We also know that factors are commutative, so perhaps you have the same answer, but the factors are switched, and that's fine. That's still the same product. 3 times 6 is the same as 6 times 3. Okay, so there you go. All right, and then if we wanted to check this, we could always do a quick FOIL to make sure we get back to our final product. Okay, so that's for 4 terms. We're going to look at factoring trinomials now, ax squared plus bx plus c. And this time, a doesn't necessarily have to be 1. So in the previous section, we looked at x squared plus bx plus c. Now we're going to see what happens when our leading coefficient is not 1. So in this case, it's 3. And we're going to look at 2 methods. And the first one is trial and error. Trial and error. All right, and then essentially, what we have to remember when we're factoring by trial and error is that we're going to do a reverse FOIL. Okay, so let me do some FOILs. Trial and error means we're going to try to populate these 2 set of parentheses to get 3x squared plus 11x plus 10. All right, and what we know from FOIL, if we multiply our first terms, so I'll do those with red squares, that's going to give us the first term of our trinomial. And then when we multiply our last terms of our binomial, that product should be the last term of our trinomial, in this case the 10. And there's lots of different ways to do this. So that's why it's trial and error. So let's go ahead and start. So when we FOIL, let's focus on the red squares first. It has to be 3x squared. Now luckily 3 is prime, so there's really only one way to do that. So we can just do 3x and x. All right, and again, that's nice because it's prime. Okay, the next things we can do, we could fill in the signs, try to fill in the signs. Notice the middle term's positive and the last term's positive. That means in our binomials, these are both going to be plus and plus. So let me fill that in at least. See how it's trial and error? Kind of doing it bit by bit. All right, and now we're going to focus on the 10. Now there's a lot of different ways to get to 10. We can do something like 10 times 1. We can do 1 times 10. We can do 2 times 5. We can do 5 times 2. So we have 4 different options. Okay? Let's start with 10 times 1. Okay, and now this has become a question. So is this true? So does 3x plus 10 times x plus 1 equal 3x squared plus 11x plus 10? Well, what we do know is that it definitely matches our trinomial for the red box and the yellow circle. We're interested in the middle term. And the middle term is in our FOIL, it's the outside and the inside. So what that looks like is we have to check, I like to call it kind of like the double chins. We have the 10x right here, and then the 3x right here. And these are positive, positive. So if we add the outside and the inside terms, does it equal 11x? And it doesn't. It equals 13x. So this is not right. We have to try something else. Okay, so what else can we try? Well, we know the 3x and the x is correct. So that means the 10 and the 1 has to be changed. Okay, so some of my eraser is working. Let's try switching the 10 and 1. Okay, my eraser's not working for that, so we can modify that. So what's another way that we can get to this product of 10? Well, we can choose maybe 2 times 5. All right. So again, 2 times 5 is 10. So when we FOIL, we do our first terms. or 3x squared. Our last terms are going to give us 10. So we have to worry about the outside terms and the inside terms, or we can do the double chins. So positive 2x and 15x. If we add those up, we get 17x. And again, that's not the 11x. So that's wrong too. So let's erase what we have. My eraser only likes to erase blue, and that's okay. We'll figure it out. All right, so finally, let me write this over. All right, we know the 3x is here to stay. Let's try something else. Let's try maybe 5 and 2. All right, because again, 5 times 2 gets us 10. We're concerned about the middle term. So if we FOIL it out, our shortcut is just to look at the double chins again. So 5x, that's positive, plus 6x. Does that finally give us our polynomial? It does. That's finally our middle term. Okay, so this is our factored polynomial. All right, and it's trial and error. Again, with the trial and error, you start with the first terms. You start with products for the last terms. And then the middle term is up for grabs. So you have to check those double chins to see if that combination gets you the middle term. All right, so that took us about 3 times out of 4, and we got it. Some people like the AC method because it can be a little bit more efficient. The trial and error is good. Let me go back up here. Trial and error is good if our first term and our last term are either prime numbers, or they don't have a lot of products. For instance, 10 is just 10 times 1 or 2 times 5. That's not that bad. But if this was like 24, 24 can be a bunch of things. It can be 1 times 24, 2 times 12, 3 times 4, 4 times 6, 3 times 8, there you go. So this, if it was 24, it'd be hard. Trial and error was pretty good for this one because 3x squared is prime, and 10 doesn't have a lot of factors. All right, a more efficient method for when we have lots of options for trial and error would be the AC method. So let's see how the AC method works. So notice it's for factored trinomials ax squared plus bx plus c. And we have an a, c right there, and this is called the AC method. So we're going to focus on the first and the last term. All right, and we're going to do this with the example 3x squared plus 11x plus 10. And your first step is to multiply a times c. So you're going to multiply the first and the last terms. So 3x squared plus 10, that's 3 times 10. Three times 10 is 30. All right, now we're going to find two numbers. Step 2 is we're going to find two numbers that add up to be the middle term and multiply to AC. Okay, some of us have seen this X before, and this is one way to organize our information. We would put AC in the top and B in the bottom, and then these other two slots would be for your two special numbers. So in our case, AC is 30 and B is 11. So two magic numbers that add up to positive 30 and positive 11. 5 times 6 is 30, and 5 plus 6 is 11. All right, so we have our two magic numbers. What we're going to do now, and this step is really important, is we're just going to make a direct substitution for b. Since 5 plus 6 is 11, we're going to rewrite 11x as 5x plus 6x. So let's write that down. So we're going to replace our middle term, or b, replace b with the two numbers. All right, so here we go. Here's our original trinomial. There's our x, or our b term. And we're going to replace 11 with 5x plus 6x. So notice we haven't changed anything. Everything's exactly the same. Common mistake is to say, for step 3, to just write x plus 5 times x plus 6. But that wouldn't work, because it would FOIL out for a leading term of x squared. So step 3 is really important, and it's really, really, really commonly missed. So I would put like a highlight over step 3 or a big star or something like that. But what we did in step 3 is we created a 4-term polynomial. And how do we factor 4-term polynomials? That's right, we factor by grouping. So that's your next step. Factor by grouping. All right, so make 2 groups of 2. Factor out your greatest common factor in each parentheses. And then factor out the common factor again. And now you have your answer. And notice it's the same as before. We did the same problem with the trial and error method. So we were just really kind of testing this AC method out. And again, and I'll write this to check, write this over here, you can just FOIL it out. So FOIL to check. And you should always check your work on an exam. So you could just multiply those out and make sure you get back to 3x squared plus 11x plus 10. Okay, so now we have some to factor on our own. Go ahead and push pause, and when you come back, you can check your answers. Okay, so for the first one, there's a greatest common factor that we can factor out. Okay, so this one, you can do trial and error. You can do the AC method. And we know it's that because we have 3 terms and our leading coefficient is not 1. So that means trial and error or AC method. All right, AC method, A times C is negative 30. Middle term is 13, positive 13. So 2 numbers that multiply to negative 30 and add up to positive 13 are 15 and negative 2. So we're going to replace 13x with those 2 numbers. Here's a life hack. Put the negative number, if one is negative and one is positive, put the negative one first. And then you don't have to factor out a negative number. All right, so again, why we did that is now we have a 4-term polynomial, so we can factor by grouping. And then we have our solution. And the last thing we need is our 2 from before. We really had this 2 the whole time. All right, so there's your solution. 2 times x plus 5, 3x minus 2. All right, number 2, no common factors. I would do guess and check on this one because 16 times 6, I'm not too familiar with that product. So I would try to factor that on my own. So guess and check. All right, so I'm thinking of ways to get to 16. 4 times 4, 8 times 2, 16 times 1. Lots of different ways, unfortunately. So let's just start trying them out. So remember, the first spot is for the first term. And then the last term is to get us to negative 6. And I know that 6 times 1 would get us to 6 somehow. But I don't think it's going to be big enough. I know these have to be opposite signs. And if we look at the double chins, this will be 4y and negative 24y. So that would be negative 20. So that's not getting us big enough to get to this negative 29. So I'm going to start over. Instead of 4y times 4y, I'm going to do 8y. (8y) times 2y. And then maybe we could try for the 6. Let's see, again, we have lots of options. 3 times 2, 6 times 1. But knowing we have to get back to negative 29, let's see, if we put a 3 here, and then a 2 here, I don't think that's going to get it either. So again, we need opposite signs, so we're looking at the difference. We have positive 4y for our first double chin, negative 24y for our second, so that's still not getting us there to the negative 29. So we have to look at a bigger difference, So maybe let's try a 16y. Okay. Oh, and now it's only erasing green. Okay, so we'll do 16y as best we can. So this will be a 16y, and this will be a 1y. And 16 times 2 is negative, I'll do a 16 times negative 2 is negative 32. And then we'll have to have a 3 here because 3 times negative 2 is negative 6. All right, so we focus on those factors. Now let's look at the double chin. So we'll have 3y here, positive 3y, and then negative 32y. And then that's what's finally going to get us to the negative 29y. Whew, that was a hard one. Okay, so let's write it, our final answer here. All right, let's look at this next one. This one has a's and b's and b squares. So we have 2 variables going on here. There's no common factor. And again, when we have 2 variables like this, it ends up working out where the first term is an a term and our second term is a b term. All right, and then everything is positive. The middle term is positive, and the last term is positive, so we know it's going to be 2 plus signs in our parentheses. And let's see, can we do trial and error for this one? I don't think this one's too bad. Let's think about different ways to get to 10. We can start with 5 and 2. So 5 times 2 is 10. And then 9, what if we try 3 and 3? Whoops. All right, because 3 times 3 is 9. And we'll check our double chins. 3b times 2a is 6ab, positive. And then 5 times 3 is 15, positive 15ab. And does that get us to the 21? It does. So there you go, 5a plus 3b times 2a plus 3b. All right, for the fourth one, let's go through our AC method since it's been a while since we've done that. So again, no greatest common factor. We have 3 terms. The first term is not a 1, so it's trial by error or the AC method. A times C, 5 times 6 is 30, positive 30. The middle term is positive 13. And so the 2 magic numbers that get us to positive 30 and positive 13. 10 times 3 is 30, and 10 plus 3 is 13. So again, we take those 2 magic numbers and we replace 13x with 10x plus 3x. Common mistake is to write that the solution is x plus 10, x plus 3, but that's not right. And you can see it's not right by foiling it out. All right, and then the next step of our AC method is we create 2 groups of 2, factor out the greatest common factor, factor out the greatest common factor again, which is the x plus 2, and then we can check by foiling. All right, and then just to do that foiling process, first terms, outside terms, middle, and last, and we do get back to 5x squared plus 13x plus 6.